Diamonds are a woman's best friend. But what exactly is it that makes a diamond shine? What is a diamond made of? Well, diamond is an allotrope of carbon. But what exactly are allotropes? Now that's a lot of questions. But don't worry, we will seek answers to all these questions in today's episode. Hello, I am Devabrata Goswami. Welcome to a glittering episode of chemistry. In this episode, we will study the properties of carbon. We will also study the allotropes of carbon, including the crystalline and amorphous forms. And naturally, the icing on this particular cake will be the exam decoded section. The food we eat, clothes we wear, and the graphite used in our pencils are all made of the element carbon. Carbon has a special status in our life. It is precious and it is everywhere. You must be wondering, why do I call carbon precious? Because life requires it. From a whale to a redwood tree to a ladybird to our cells, everything contains carbon. Carbon is represented by the symbol C. Its atomic number is 6 and atomic mass is 12.01 grams per mole. As for the electronic configuration of carbon, it is 1s2, 2s2, 2p2. The badminton racket you use contains carbon too. How? Well, the wires are made of carbon fiber reinforced plastics, giving superior strength, stiffness, and good fatigue resistance to the racket. Carbon fiber reinforced plastics are also used in biomedical field in bone plates, joint prosthesis, ligaments, and hydraulic motors for artificial heart implants. Carbon's special talent is that it's seriously good at making connections. I mean that carbon can bond with other carbon atoms to form long chains or rings. This ability of carbon to form covalent bonds with other carbon atoms is called catenation. Carbon also has a unique ability to form p-pi multiple bonds, that is, double or triple bonds with itself and with other electronegative atoms like oxygen and nitrogen. Due to catenation and multiple bond formation, carbon shows a number of allotropic forms. Remember, in the beginning of the show, I had talked of allotropic forms and allotropy? Well, let's try and understand what these heavy-duty words mean. The phenomenon of existence of an element in different forms which have different physical properties but similar chemical properties is known as allotropy. And the different forms of an element are called its allotropes or allotropic forms. Carbon is one of the elements which shows allotropy. It exhibits many allotropic forms which can be both amorphous and crystalline. Graphite, diamond, and fullerenes are the three crystalline allotropic forms of carbon. Let's begin with graphite, which is a soft, black, and slippery solid. This is because it cleaves easily between the layers. It has a metallic luster and conducts electricity. Because of the soft and slippery nature of graphite, it is also used as a lubricant. An important feature of graphite is that it is used as a dry lubricant in the machines which run at high temperatures where oil cannot be used. Do you know that the lead in a lead pencil is actually graphite? Graphite is also used as a refractory material for making crucibles. The unique property of these crucibles is that they are inert to dilute acids and alkalis. Graphite, being a good conductor of electricity, is used in electrotyping and electrical apparatus. It is also used in the manufacture of gramophone records. What gives graphite its properties is its structure. Graphite has a layered structure. Each layer is composed of planar hexagonal rings of carbon atoms in which the carbon-carbon bond length within the layer is 141.5 picometers. Each carbon in the hexagonal ring undergoes sp2 hybridization and forms 3 sigma bonds with 3 neighboring carbon atoms. The fourth electron forms a pi bond. The electrons are delocalized over the whole sheet and are mobile. The layers are held together by van der Waals forces and the distance between two layers is 340 picometers. Time to take a quick break. I have lots more in store for you, so stay tuned and keep thinking. Take a look at this question and see if you can answer it. The question is, which compound of carbon is responsible for global warming? To know the answer and to build up your knowledge about carbon, you could log on to our website www.topperlearning.com. I will see you in just a bit. Welcome back. I am Devabrata Goswami and you are watching Chemistry. We were discussing the structure of graphite before the break. If you remember, I had also asked you a question. The question was, which compound of carbon is responsible for global warming? And the answer is carbon dioxide. With this, let's move on to the other allotrope of carbon, diamond. Diamonds are used as precious decorative stones in jewelry because of their unusual brilliant shine. They are also used in tools for cutting glass and rock cutting drills because of their hardness. In diamond, each carbon atom undergoes sp3 hybridization and forms covalent bonds with 4 other carbon atoms at the corners of a tetrahedron. The structure extends in space and produces a gigantic 3-dimensional network of interconnected covalent bonds. A diamond crystal of gem quality consists of a huge number of carbon atoms covalently bonded together in one enormous molecule. Since breaking a diamond crystal involves rupturing of a large number of strong covalent bonds, diamond is extremely hard. Let's now take a call from one of our young callers.
Diamond is covalent, yet it has high melting point. Why?
That was a nice question. As you know, diamond has a 3-dimensional network involving strong covalent carbon-carbon bonds which are difficult to break. This results in the high melting point of diamond. Well, that was the answer to your question. Now, here is one question from my side. Can graphite be converted to diamond? Think hard. And the answer is yes, we can convert graphite to diamond at very high pressures and temperatures. Let us now consider another series of carbon allotropes called fullerenes. They were discovered in 1985 by Harold Kroto, Richard Smalley, and Robert Curl. Fullerenes have a cage-like structure. For instance, C60 molecule has a shape like that of a soccer ball and is called Buckminster Fullerene in the honor of the architect R. Buckminster Fuller, who used similar ring arrangements in designing a type of structure called geodesic dome, which is a spacious, lightweight and strong building design. But can you tell me how fullerenes are prepared? They are made by heating graphite in an electric arc in the presence of inert gases such as helium or argon. The vapors formed are then condensed to form sooty material which consists of mainly C60 with smaller quantities of C70 and traces of other fullerenes. We have discussed crystalline forms of carbon, graphite, diamond and fullerenes. Let us now discuss amorphous forms of carbon. Coke, charcoal and lamp black are all amorphous forms of carbon. Lamp black is also known as carbon black. Let us first start with coke. Coke is a grayish-black solid which is mainly used as fuel and reducing agent in metallurgical operations. Charcoal is soft, brittle, lightweight, black and porous form of carbon. Charcoal is usually produced by heating wood, sugar or other substances in the absence of air. Carbon black or lamp black is obtained when substances rich in carbon content like kerosene or oil are burnt in limited supply of air. It is used as a pigment in black ink. Now you know quite a bit about carbon and its allotropes, and it's time to test your knowledge. But before we head to exam decoded, let's take a short break. Welcome back. This is Devabrata Goswami and you are watching Chemistry. Today we are discussing the allotropes of carbon. I am sure you have got the drift of the topic, but nonetheless, let's do a short recap. In today's episode, we learned that carbon shows catenation and forms multiple bonds. It forms a number of crystalline and amorphous forms. The crystalline forms of carbon are diamond, graphite and fullerenes. Graphite has a two-dimensional layered structure. Diamond has a three-dimensional network structure and fullerenes have a cage-like structure. Coke, charcoal and lamp black are amorphous forms of carbon. Well, I am sure you will remember this. But you also need to be quick because exam decoded is about to begin. Welcome to exam decoded. Hope you paid attention to the recap of important points because you are going to need them for our rapid fire round. The rules are simple. I will ask you 5 questions of 1 mark each, and you will get 5 seconds to answer each one. Then we will see how your marks reflect your readiness for the exams. So let's get started. Here is the first question for you. In diamond, carbon atoms are held together by A. Covalent bond, B. Ionic bond, C. Coordinate bond, D. Hydrogen bond. And the answer is A. It's covalent bonds. Now for the second one. The structure of which of the following is a two-dimensional layered structure? A. Graphite, B. Diamond, C. Fullerene, D. None of the above. Well, the correct answer is A. Graphite. Here is the third question. Which of the following is the crystalline form of carbon? A. Diamond, B. Coke, C. Carbon black, D. Charcoal. If you answered A, diamond, then you are absolutely right. Fourth question. Graphite is an allotrope of carbon and conducts electricity. True or false? The answer is true. Graphite is an allotrope of carbon and conducts electricity. And finally, what is the hybridization of carbon atoms in diamond? A, sp, B, sp2, C, sp3, D, sp3d. The answer is C, sp3. Well, now it's time to compare your scores with our scorecard. Mark yourself honestly, because only then you will be able to prepare and perform well in your exams. If you have scored 5 on 5, you are today's high flyer. My advice is to continue with the pace because you are on the right path. 4 or 3 on 5 makes you an achiever. You are doing well, but perhaps you need to work a little harder to clear your concepts. If you have scored less than 3, then you are still a learner. But don't worry, because we have got tons of practice tests and special tips for you on www.topperlearning.com. And here is one special tip from me. It's always better to analyze the exam trends for a particular topic. That's the way to study smart. So let's analyze this topic. Allotropes of carbon is from the unit the P block elements and carries 7 marks. So it is critical from the examination point of view. Usually, short answer type questions for 1 or 2 marks are asked, which test your knowledge ability. Now that we have analyzed this topic, let's see how questions should be answered. Because ultimately it is the questions that will get you the marks. Better presentation, better chances of topping. This question can come in your exams for 2 marks. Differentiate between the structure of graphite and diamond. Since this is a 2-mark question, you will need to write at least 2 points of difference. The first point will be that graphite is a 2-dimensional layered structure in which each layer is held together by van der Waals forces. Diamond, on the other hand, is a gigantic 3-dimensional network of interconnected covalent bonds. This difference will fetch you 1 mark. For the second point, write that in graphite, each carbon atom undergoes sp2 hybridization and forms bonds with 3 other carbon atoms. In diamond, each carbon atom undergoes sp3 hybridization and forms bonds with 4 other carbon atoms at the corners of a tetrahedron. This difference will fetch you another 1 mark. Well, that's all on allotropes of carbon. Now that you are an expert on this topic, tell me, what are carbon nanotubes? Don't know? Seek the answer. If you already know the answer, you can log on to www.topperlearning.com for more questions. But keep thinking. This is Devabrata wishing you a smart preparation.